Welcome to the React Show, brought to you from occupied Serrano territory by me, your host Thomas, in a beautiful high desert morning, episode 76. You probably use TypeScript because you think it makes your programs better, but I bet it actually makes them worse. A good program is a well-designed one. And we're always programming on some kind of time or money budget, right? So if we spend extra time on typing with TypeScript, where do we steal the budget from to do it? Do we steal it from design? A few days ago, I rode my bicycle packed with all my camping and podcast gear out to Joshua Tree National Park from the LA area. It was quite an adventure, including 75-mile-per-hour wind gusts, down trees, and even attempting to hoist my bicycle up a dry waterfall to avoid having to ride on this really sketchy, dangerous highway through this canyon. But an adventure is exactly what makes this kind of thing worth doing, right? I've just been having an awesome time since then, camping out in Joshua Tree with the canyon wrens while writing podcast episodes and programming. I know, I can't complain, right? Anyways, if you want to hear more about my bicycling adventures and camping in the wilderness, I'll chat about it on the after show. Check out the show notes for details. And while I was riding my bike, the truth is I kept thinking about TypeScript. So I get asked all the time what my opinion is on it. An awesome guest we recently had on the show, Evan Walter, asked me about it too. Well, I decided it was finally time to speak my truth on it in detail. It seems like a lot of people are surprised when I tell them I don't really use TypeScript. And I feel like I always have to defend myself. So, you know what? Here goes. I don't know if this is defending myself or I don't know. I'm just going to explain why I don't use TypeScript very often, or at least why I don't hype it. And one of the downsides of recording out in Joshua Tree is apparently there's mosquitoes. So, if you hear me swatting at things, that might be why. But yeah, so it's sort of always assumed, I think, at this point in sort of the more serious JavaScript web app React community that you use TypeScript. If you're, any good at what you're doing, you're going to use TypeScript, right? Well, I am certainly serious, and many people have told me I'm not bad at programming. So, all right, TypeScript's time has come. It's time for me to cut it back down to the place it deserves in your toolbox, but not the first implement you reach for. But before we can get into the why, though, we have to talk about programming in general and what makes programs good. The only reason I've ever heard of people using TypeScript is because they think it makes their programs better in some way. Usually catching, type-related bugs earlier, but sometimes for other reasons. The bottom line is TypeScript seems to exist because people think it makes their programs better, or at least, makes them a better programmer or something. So first, I think we have to analyze what makes programs good and what makes us as programmers good programmers. A quick summary of just programming languages in general is that they literally exist to allow us as programmers to create abstractions. Like, we could write our programs directly in machine language, right? Or at least in general purpose, machine language that gets translated to different architectures if we're writing in a higher level language purely, for the sake of cross compilation or something, right? But we don't do that, right? Especially as web developers, we are far removed from writing machine code directly. There are many layers of abstractions between us and the hardware. Abstractions. Exactly. Abstractions are what makes programming programming. At least in my opinion. And programming languages, have a reason. It's like what gives programming languages a reason to exist at all. Abstractions are what allow us to write programs much more quickly and effectively than we could otherwise. So to me, it all comes down to abstractions. Programming is abstractions. Like I'm sure if you've ever programmed with me, it's something you're going to hear for certain quite often, whether it's in code reviews or discussing the design of something or whatever it happens to be. Programming is abstractions, and that's what I care about, and I think for good reason, which we'll get into. But not all abstractions are created equal, right? So I once worked on a web application, it was about 10 years ago now, that was written in JavaScript on the front end and Java on the back end. And I think, JavaScript at the time, I'm sure we used jQuery. And I think at one point we even upgraded to like Backbone or something, really, groundbreaking, I know. The back end code, though, was incredibly verbose. It was so verbose, in fact, that I just got sick of writing it. It felt like my day was basically filled with creating or like trying to get my editor to create or refactor endless getters and setters and interface classes. Like Java has certainly gotten, I think less verbose since then. But at the time we were using, pretty much like quote cutting edge Java. It was so bad, in fact, that I basically stopped writing Java code. And it's not because I just worked on the front end, although I did do a lot of that because I didn't want to work on the back end. But I actually wrote my own Lisp to Java code generator. So my Lisp code was a tiny fraction of the Java code that it output, but the output did exactly the same thing. So my Lisp program was tiny, did the same thing as tons of lines of Java code would do, but I didn't have to write near as much. It was fantastic. I was so happy. It made working that job so much better. Obviously, this isn't groundbreaking. Many programming languages that exist, they exist to compile down to other languages. And many times, they exist purely to sort of create and allow us to use higher levels of abstraction. Somebody's like, oh yeah, C is great because it runs on a bunch of stuff, but I want to also be able to use anonymous functions, and I don't want to wait for C 29, 2029 or whatever it happens to be, And so they write something that compiles down to C, but allows you to write in higher level abstractions. It's great. Definitely the route a lot of programming languages have gone. So yeah, it's not groundbreaking. Is all I'm really saying is I did something that was cool. I thought it was awesome, but it wasn't groundbreaking. But it gets back to my sort of main point, and that is that programming languages are all about abstractions. But you also need the right abstractions. And your programming language, and this is critical, it needs to enable you to use the best and most effective abstractions. The Java code that we wrote was a horrible mess. It was incredibly difficult to work with, and it was riddled with endless bugs. I've worked on many Java projects, and I am convinced they all end up this way. Now, I don't actually necessarily directly blame Java, although you could argue it's probably what I should do. But I think the real problem is that Java just makes it difficult to create some abstractions that would make your code better, that would make it so you don't have to write as much code to accomplish just as much, that would not leak things, that type of stuff. But in the Java world, at least when I worked in it, I haven't worked in it as much recently, but when I did, the community even sort of discouraged creating new abstractions. So when I worked at this company, I originally attempted to create some better abstractions directly in Java using what they call the Reflections API. So it's like something the Java language, provides essentially. And it was cool. The end result was you could write much less code to accomplish the same thing, right? Abstractions, great, awesome, But it was wildly unpopular where I worked. And in general, basically the attitude was that if you reached for reflections, then you were doing something wrong. That's not what you should be doing. You got to use Java the way Java's meant to be used, the way it was, designed, blah, 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 right? Well, this is actually an attitude I still see in React and, web application, like the TypeScript community as well. It's not near as extreme, I think. There's definitely a lot more openness, around this, but I think it's this very similar attitude. The attitude is that programming languages should actually place restrictions on us as programmers so we don't make obvious mistakes. This is sort of Java 101 in my opinion. The theory that good programs are programs that any programmer can just jump into and start writing code in and not have to worry about introducing a type error or whatever. But if good programs are really about good abstractions, what does that have to do with programmers, being able to quickly jump in and start writing code? It doesn't have anything to do with that. In fact, it's the opposite. And this actually is, I think, tied into a much larger point. A lot of people will be like, well, why do we use Java then? Why do we use some of these other languages? Without going too far off on a tangent, I think a lot of it is actually based more on sort of capitalism and our ties into that. So a lot of the programming that we do is via or for companies, right? And companies do want programmers that are interchangeable. They want us to be cogs in a machine, right? Like they want to like a programming manager, a company, their biggest dream, right, would be if they could just grab any programmer off the street, plug them in, and they just start cranking out code. And, that's their biggest dream, right? And so I think really things like Java are kind of their attempt at that. Like, oh, we're not going to let you do most things, but the advantage of that is it should be easier for us to pluck a programmer off the street and just have them start writing Java code. Like if you compare that to some of the Lisp projects that I've worked on, it's the complete opposite. Like it might take you months to learn the Lisp project well enough to write any useful code. Whereas yeah, it's kind of true. In a Java project, you can pluck someone off the street and they can start writing code. But the big difference is the quality of those projects is light years apart. The Java projects, 100 million lines of code and just full of bugs, and every line you write leads to more bugs. The Lisp one, yeah, it took you longer. You can't just use any old programmer. You got to have a programmer that actually knows what they're doing, maybe. But the end result is you're going to pay a lot less for it, and the quality is going to be a lot higher. You're not going to have to rewrite it every 5 years. Obviously, if you do things right, and we'll get into that more. But basically, I think that's I went on a little side tangent, but my theory on why a lot of this exists, and even I think this ties into TypeScript, a bit as well. TypeScript sort of enforces you. It places restrictions on you. Like if you actually use it, you're, not just sort of optionally using it, right? But anyways, so sort of going back to the main topic, think about it this way. React is an abstraction built on JavaScript and HTML, right? So it's an abstraction that you had to learn before you could effectively work on a React project. So we'd be better off without React then? If we just wrote everything in plain JavaScript without React, then as a programmer, you don't need to learn the abstraction of JavaScript and React. You'd only need to learn JavaScript. That's better, right? Like just, you can just sort of plug us in a little bit easier, right? Or I think another example would be like, what about functional programming? Would we be better off if we restricted ourselves to programming imperatively? What about, I don't know, state machines? They take time to learn, so maybe we shouldn't use them either. My point is that the right abstraction is what really matters. Like, obviously my answer to those questions is no, it's definitely worth learning those and having those in your toolbox, right? This is what we call design, finding the right abstraction, using the right abstraction, implementing it correctly. A good programmer, is one that can design good programs. A good program is a well-designed one. It uses the right abstractions in the right places, in the right ways. That's what we want in a program, And yes, this might mean you have to learn a new abstraction to begin working with a program, but it's all about abstractions anyways. So that seems like the natural conclusion, right? Good programs are well-designed programs. If you've done any significant amount of programming on projects with other people, you will certainly have come across those areas of code where you change something and it just breaks stuff somewhere else. It's like the bugs just start crawling out of the woodwork the moment you touch anything. It's definitely the most frustrating experience any programmer could ever have. And guess what? This comes from TypeScript programs just as easily as plain JavaScript or Java programs. That happens when the program was badly designed, or more likely not designed at all. I mean, let's be honest. That's the world we live in, right? Most of these programs weren't really designed, So the program, it might compile without type errors, but it doesn't matter. The program still sucks. It wasn't designed or designed well. Now, if you do research into what actually causes bugs in programs, it's kind of hard to necessarily pin things down specifically to design. But when I looked at this body of research, and I've looked at it a number of times at this point, I think that's effectively what it's communicating is, a lot of the studies will look at more specific things, but when you break it down and sort of look at it, on sort of a meta-analysis, I think what it shows is that the biggest source of bugs are really related to design. Programmers jump into a code base and they don't understand what some piece of code does. They think it does one thing, and so they try to use it that way, but it actually does something else. Or they're like, oh, I don't know how to make it do what I want to do. I'm just going to sort of force it, We've all been there. It's like your boss is like, okay, this has to be done in a week. And you're like, well, this code is just not set up for this. It's not made for this. Well, it's got to be done in a week. All right, well, here goes. And, you start piling that on top of each other. Anyways, you can write it in TypeScript. It might compile fine without type errors, but it really doesn't matter. Your program still sucks. So anyways, there's a lot of research into this. My conclusion, and I think other people would, some other people at least would agree, comes down to design is really the source of the biggest, most fundamental bugs in the program. And yes, there have been studies that have shown that using a static type checker does improve the overall quality of your program. I'm not going to deny that. It's undeniable. But here's the thing. This is with all other things being equal. So if all other things are equal, then static type checking undeniably improves the overall quality of a program. But there is one very key element to that statement. It's where I said all other things being equal. To explore what that means, we need to take a look at another aspect of programming, the budget. It doesn't matter whether you are programming for yourself, someone else, or a company. There is always an explicit or at least an implicit budget. It might be as simple as I work on this in my spare time to extremely detailed budget documents. Either way, there is a budget. And the most important aspect to a good program, like we've established, is good design, choosing the right abstractions. Good design, though, is costly. It takes time, a lot of time, especially up front. It always pays off, in my opinion, in the long run, but it's very costly up front. And when we look at a well-designed program is one that is easy to extend and maintain in the future. And this means that it is overall cheaper, it costs less overall over the length of the project, but it might have a very steep upfront cost, that initial design cost. So we actually, if you're curious about like some of my thoughts more in depth on design and my experiences, with well-designed projects and how to get there, we definitely have some past episodes on that. So I'm not going to go into it in like a ton of detail here. But sort of the summary is that the best approach I have found revolves around prototyping to some extent. So to create the right abstractions, you have to understand the problem space well. And the most cost-effective way I've found to do this is to create prototypes. It's not the only way. You can learn how to create the best abstractions other ways, but it's the most cost-effective way I've found. But regardless, even if you don't create prototypes, I can basically guarantee you that your first attempt at a program will just not be the best design fit. You're going to learn things, while you're writing it, right? You'll learn like better designs as you program it. And after you finish the first version, you'll have better ideas too. This is always how it works. Like talking with your buddies at work, like, oh yeah, well now that I see how we're actually doing this or what they actually wanted, we should have done it this way, right? Like that happens. That's how it works. Or even if it's your own project, that's the nature of things. So if you have a limited budget, where does the time to design actually come from? How much of your time or money have you dedicated to getting the abstractions right? If you're putting your time into things like static type definitions, is that taking away time from creating good design? You'll probably be throwing away the first few versions if you are really trying to create good design. So again, what's the point in spending some of your precious time on type definitions if you're just going to throw, this code away or most of it away, or it's going to evolve, right? This really gets to my main point. We have a limited budget, and the best thing we can do with this budget is to create the right abstractions, while also obviously getting the program to meet all of its feature requirements and be well tested. But like given the baseline, we have a functioning program that solves the user's needs with a good user experience, blah, blah, blah. Like the best thing we can do is give it good design, choose the right abstractions. And so the reality is I don't actually have a problem per se with TypeScript. In fact, I'm really glad it exists. You might be surprised to hear that at this point. But static typing is actually really useful. Once I've nailed down the right design and implemented all the right features, I often go back and add some type definitions, especially to things like API boundaries. Catching bugs or more bugs, up front is certainly something that I want. So I'm glad TypeScript exists, but I never want to do it at the cost of good design. And this is really the problem that I've identified. What I see in practice with TypeScript is that people often use it right up front and often, in my opinion, in place of actually doing design. The thinking seems to be, if I'm using TypeScript and carefully speccing out every interface, then my program will just be high quality or higher quality, But this really, in my experience, my opinion, couldn't be further from the truth. In one sense, yes, you will have less type-related bugs. Yay! Great! I mean, that's good, right? But overall, type-related bugs are kind of a minor aspect of a good program. Like I said earlier, you have to, you can have the most like perfectly typed TypeScript program that, uses all the wrong abstractions, and is a nightmare to work with. I've been there. It's often how things go. And to put a finer point on it, what even is static type checking anyways? So TypeScript uses what is called static type checking. This means that types can be checked for issues at compile time. This doesn't mean that JavaScript is untyped. You'll often hear this too. People be like, oh, got to use, TypeScript. It has types. JavaScript has types. TypeScript doesn't add types to JavaScript. All it does is make it so you can catch those type checking violations earlier in the process, right? So JavaScript has type checking. It's called dynamic type checking. This means that JavaScript does have types, but those types are checked at runtime. So what TypeScript gives you is just one little step beyond that, type checking at compile time. Again, like going back to this whole budget, discussion, the question is, how much payoff does static type checking give us relative to other things like design and a new one I haven't really talked about yet, testing? And this gets to my second reason for not caring that much about TypeScript, testing. So I put a lot of effort into writing high quality tests. These tests cover all of the most, critical and even less critical paths if possible. And if there are type errors, I generally will still catch them before deploying because my tests will trigger JavaScript's runtime dynamic type checking. So I guess the other side of this is I do see a lot of projects that use TypeScript but don't have good tests. And I again feel like this is a misplaced use of time. To me, the quality of a program follows generally this hierarchy. The top of the hierarchy is good design, good abstractions, right? Once you get that right, the next thing on the rung of this ladder is good tests. Are the tests good? Do they cover things well? That kind of thing. Once you have those two, what I call sort of foundational pillars figured out, then you can move on to things that have maybe a more minor impact, like static type checking. TypeScript is overhyped, and it leads to worse programs for exactly those reasons. Instead of putting time into design and testing, people put their time into static type checking. I have seen this over and over and over again on projects. They are obsessed with TypeScript and getting all their types right. And I'm like, why are you putting your time into this? Like, look at this code. This isn't a good design. Did you even think about this design? And the answer is always no, I didn't. So I'm like, I don't know. It just feels wrong. Or I'll be like, hey, this actually happens more than the other one even. So I see you added this new feature. Could you add a test for it? Oh, I don't have any more time. This has to get deployed now. And you're like, okay, well, I would have much rather have had good tests than have your type checking implemented. So yeah, I think TypeScript is overhyped. I think it has its place and I do use it, but I often see people using it in place of good design and good testing. So while for most production applications, like I said, I do employ high quality tests and even some static type definitions, I have also experimented with only focusing on good design. Like I spent most of my budget on it. So I wrote a production application. It was, by myself that is in use by real users. And I wrote essentially no tests and I have no static type checking. So this was in primarily in Lisp, React, JavaScript. I spent probably half of the development time on prototyping and design. I went through so many iterations. I don't know. I rewrote probably the bulk of the program at least 4 times, if not more. I kind of didn't keep track, right? But the truth is, the end result, what I have now, is one of my favorite programs to work on. And by far, one of the programs with the fewest bugs. And the best part is the type of bugs that do exist. If there are bugs, they don't usually actually break anything for the user. And working with this program is just an absolute joy. Like, I love it. I'm like, oh, yay, I get to work with this. Like, it makes me so happy. Like, I'm not dreading it. Even though this program is many years old at this point, gone through many iterations, many feature changes, the whole 9 yards, I still love working on it. And every time I add a new feature or change how something works, it's been easy to do and no bugs are jumping out of the woodwork. And it's really the experiment that cemented my viewpoint on static type checking. It's not like I have had this like sort of opinion for a while that I kind of felt like it was sort of overhyped. But this program really cemented this viewpoint in my mind. And I proved, at least to myself, that by far, the most important use of my time is design. I don't have type bugs in that program I was talking about because of good design. This is another thing I feel like people don't realize. It's in good design, I don't need to, the programmer doesn't need to mentally keep track of a whole bunch of different types. Like, oh, can this be null or undefined or whatever? In a well-designed program, those things are, natural and obvious. So you just don't have to worry about it. And this is the thing that I've noticed in my, React and JavaScript programs too. I don't usually have type issues because I always make sure to create good type design. I'm like, even I call it like sort of a mini design pattern, right? Oh, before I rant about, my mini good design patterns, thought I'd hang out with this little stink bug crawling up the cable for the microphone. Hey, buddy, I think it really just wants to hear more about TypeScript. Is that what it is? I don't know. I'm guessing. He hasn't really said much, but anyway, so I like to have this approach where, if you look at my code, you'll notice that I rarely ever let the type of something change. You'll see that even in error cases or before something is initialized, I usually set the variable to the same type it will be throughout the life of the program. So many people focus on type definitions without just being like, oh yeah, if I never change the type of something and the type is obvious by its use or naming or API, then I just really don't benefit that much from static type checking. It was actually kind of funny when I was writing this. I was like, you know what? I've run into so many times now when I've gotten other people's updates on a program and I go to build it and I'm like, yo, it's failing the type check, whatever. And oh, sure enough, there's some bug or whatever, right? And I'm like, it seemed weird to me for a while. I was like, why don't I ever get this? And obviously it's, maybe I wasn't doing TypeScript, so I wasn't getting it catching it at compile time, but it wasn't happening in production at runtime either. I'm like, what is up with this? Why does this happen? And I really think a lot of it's because of this design pattern. When I design my programs, I also design the typing. And it's not me looking at it and trying to make it past the type checking. It's me looking at it and being like, okay, what is the most intuitive to a human for this type to be? And sometimes I have something that does change type, but in an intuitive way, where I'm like, oh yeah, it would make sense that this would be a different type in this case. And the programmer, whoever's using this should, understand that. And so I don't know, it just hasn't really been as much of a problem for me. So, maybe as another takeaway from this is something you could try is, just focusing more on the life cycle of your types in general, not just, the type definitions, but what should this be typed? Should it change? And sometimes I'll even create another variable that represents essentially the same thing, but covers a different type because I'm like, okay, I can see how in the future somebody else is going to come into this program and they're going to think it's this type because of how it's being used here, which will introduce a subtle bug they might not realize, and yes, again, you could have TypeScript and type this all out, but then what's going to happen? They're going to go implement it and, oh crap, my program fails to compile. I messed up this type. I got to go refactor my work, Whereas if you're just designing good types up front, the programmer comes in and goes, oh, okay, obviously in this case, I need to use this one. And then they just use it and their code just works and you move on with your day. You don't have to mess around with a failed build because of my types or whatever, And yeah, so I do have some value for it. And I think place I often use it will be like API boundaries and stuff. Like that's great if it's typed, but even then I find that if you design your APIs well, it's not as important again. I think this really becomes more important when things aren't designed once again. But this also brings me to my final point, and this is specifically about TypeScript itself. So in my opinion, TypeScript it's just not a very good language. It's incredibly verbose as far as static type systems go. So referring back to the whole budget thing, I use static type checking in Lisp and Haskell and other things way more than I do in JavaScript. And that's because TypeScript takes a lot more time for the same results. So there's this algorithm called the Hindley-Milner type inference system, right? That we've had for a long time, decades. And some of these systems I mentioned earlier use it. And it's really awesome because basically the way it works is it will analyze your program, figure out all the different possible types, based on the way you've used things. And it'll let you know if you've done something that doesn't make sense. It'll give you compile time type errors. And it'll let you know where you can define types to give it more information to provide more of an analysis at compile time to the point where it can cover your entire program, just like TypeScript would. But it requires way, way less work. And this is really what kind of kills TypeScript for me. I'm just like, why? Like, I imagine it's probably related to being a superset of JavaScript itself or something. I don't know. I don't really know the details. All I know is that it takes a lot more work to properly specify types in a TypeScript program than in other languages. So ultimately I would love if what we really had was sort of an extension or a superset of JavaScript that worked more like I've seen in other languages that use inference to figure out types for the most part and don't really make you do so much extra work. So basically, to sum it up, TypeScript is, in my opinion, very costly for the benefits it provides. So sure, in some cases, I reach for it as a tool, but it's very far down in my toolbox. Like I do a lot of things before I pull out typing. Or static type checking, I should be very clear. So it's just really far down. And I think if you're someone that's really into TypeScript, and even if you're not, actually, what I would recommend doing is just maybe try and experiment. Maybe start a new project, or as you're starting a new project or something, try to actively allocate more time to design and less to typing and things like it. Sort of, there's a lot of things in that sort of TypeScript range. I think some types of documentation is fantastic. I document apparently more than most people, but going through and documenting every tiny little thing in your DocuScript or whatever is also kind of not that useful. Like there's useful anyways, my point is more like there's a lot of little things that I feel like we do as programmers that take a lot of time that don't produce a lot of benefit. Whereas design and abstractions, yes, they take a lot of time, but they produce a huge amount of benefit. So my, sort of suggestion would be, if you get a chance, just try to go to the extreme. Just be like, all right, I'm still going to make a functional program. I'm still going to implement the features. I'm still going to do it in the same amount of time, but I'm going to put way more effort into the design and the abstractions. I might rewrite it. I might do whatever I have to do. I'm going to try not to write TypeScript definitions where, I'm going to try not to focus on all the little stuff. I'm going to try to focus on good design. And just as an experiment to see how it works for you. I mean, maybe you're different. Maybe it's just me that works this way. I don't know, but I suspect this is how it works in general. And, it might be interesting to see that experiment for yourself. And ultimately, I think me talking about it is not near as useful as any sort of experiment like that. So, if you get that opportunity, it doesn't even have to be a big project, but definitely something that you intend to keep going for a long time. Like, I think that's where you can really start to see the benefits. And okay, for example, it could be a really simple program. Like, I remember in college, I don't know, I think I was using some like really stripped down version of a Linux desktop environment or whatever the reason, right? I wanted to have a nice graphical interface to do some very common things that I'm sure you guys are all going to laugh at me that my system couldn't do. But like a volume control and, other sort of little UI tweaks that my stripped down desktop environment didn't have. And I don't know. I think partially I was just like, I wonder how it works. I want to implement it myself. So I just wrote these small, they're probably like 100-line programs, like little GUI programs that, I could hit a key on my keyboard and it would pop up a UI and show me some information, right? It can be something like that, something that, you would probably keep around if it provides some use for you, maybe it pops up and shows you the temperature on your CPU or whatever. You can learn a little bit about, how that works along the way, but then also just heavily focus on design, even on a tiny program like that, and just see how it works for you. See how it works long term. All right. So yeah, that is TypeScript. That's why I don't usually mention it on the show. It's just not that important to me. I would love, so I know this is a thing that, is bound to draw some strong emotions within the community. But I'm curious to hear what you all think. If you actually listen through this, do you agree with me, or do you think I'm missing some points when it comes to TypeScript? Or maybe I'm just different than you. Do you find it actually provides a lot more value than I find it provides me, Anyways, I would love to hear from you. Definitely send us a message, thereactshow.com. We'd love to, I'd love to learn more, So yeah, like always, thank you so much for joining us. I'm starting to get a little bit chilly here, sitting between some rocks in my makeshift recording studio. So I'm going to get going and get recording this after show for you all. But hope you have a great rest of your day. Hope you enjoyed this little chat about TypeScript. Love to hear what you think. Hope you have a good one. Take care. See you later. Bye.